try to solve another Leetcode problem, 967, number of same consecutive differences. So we are given two integers n and k. So n is the length of the number. So for example, there are 3 digits. N is the number of the digits of this number. So it is 3. So for example, 181. So k is the difference, consecutive number difference. So for example, 1 to 8, the difference is 7 because 8 minus 1 is 7, and 8 minus the right one is also 7. So we're gonna find such combinations. Yeah, normally for such kind of problem, we need to check what is n and k. So n is a really small number from 2 to 9, and k is also really small from 0 to 9. Yeah, it makes sense because for a single digit, so the maximum difference may be 9 and the minimum may be 0. Yeah, so if this n and k is really small, we can solve this problem by backtracking. So for example, if this k is 7, maybe the first number is 1, and then we're gonna try 2, 3 until we find 8. And for the 8, we're gonna try from 0, 1, 2 until we find the answer. It is 1. So we find a result 181. And then we can continue to find all others. So let's prepare the backtracking. So we're gonna define a backtracking function. After that, we're gonna call the backtrack. So after we call the backtrack, so inside I'm gonna prepare an empty string. So after call the backtrack, I'm gonna return the result. Yeah, but how can we define this backtrack function? I'm gonna prepare an answer as my result. So answer gonna be a string. So if this length of the answer equal to n, so I gonna put it inside my result array. Yeah, I gonna turn this string into an integer and gonna have a return. So if the length of the answers is more than n, it means it is not possible. So this result is not possible. I'm gonna have a return, and then I'm gonna check all the numbers. But currently, this number gonna be a string. So for say in 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yeah. So if not answer, what are we gonna do? So if the answer string, if this current string is empty, this is from the beginning. So if it is empty and this C cannot be 0 because there's no paddings like 0, 2, 0, 4, 3, it is not possible. So C should not equal to character string or string 0. Yeah, character 0. If C is not equal to 0, so we're gonna start the backtracking. So backtrack C. If there is answer, and we're gonna use the absolute of the odd with answer minus 1 and minus the odd of C. If this is equal to k, so this is according to the description. If it is equal to k, this means two consecutive numbers. The difference of two consecutive numbers is 7 maybe. This k is 7, maybe equal to k. If they are equal to k, I'm going to do the backtracking. So the backtracking would be the answer plus c. So this would be the entire code. It is not so difficult. Basically, it is exactly the same like the Leetcode problem 14, 15. Yeah. So as you can see, the backtrack structure is nearly the same. Maybe all the backtrack structure is the same, but we need to find a way to, we should use the backtrack, and then we're gonna find a way to write the backtrack function. Normally it is not so difficult. We just need to turn the descriptions of the problems for our backtracking conditions. So basically there are two conditions of the if tag. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. It is a little bit slow. Let me submit it again to try. Yeah, it's really slow for me. Yeah, now as you can see, the speed should be okay. Yeah, because this is just a random time. Now let's analyze the time complexity. So for this time complexity, basically we're gonna find how many such kind of combinations. Yeah, because this k is really long, it can be this n is really long, and n can be 9 maximum, and this k can also be 9, 1 to 9 maximum. Yeah, it's really difficult to check, but let's just have a basic idea of how to check the time complexity. So here, yeah, I think this is going to be difficult. I'm not sure if I can analyze the time complexity for this problem. Yeah, let me just try. Yeah, because basically this is trimming for the backtracking. If it is more than n, we're going to trim it. So this n maximum is going to be 9. But if this n is 9, actually, maybe it's not the maximum time complexity. Maybe n equals to 4 or 5. Maybe, yeah. Maybe this k equals to 2 or 3. Maybe that's going to be the maximum time. But we have to check all such kind of combinations. Maybe this k equal to 1, it's going to have the maximum. So what if k equals to 1? And yeah, so if this equal to 1, yeah, yeah, let's just check the function from here. So for here, this is a for loop. So this is a n equals to 10. So this is a 10. But for here, we have a check. We're gonna check n equals to k, and then we go to the backtrack for the next one. Yeah. Yeah. So for each of the time, it's gonna be 10 possible result, and how many times it depended on the length of the n. Maybe it is 10. So if this n, maybe it is 9. So the time complexity maybe yeah. So the first character cannot be 0. So it is so this is for the first one, it's gonna have 9 different cases because the first one cannot be 0, and then for all others it can be 10 different cases. Yeah. So basically it is 10 to the power of 10 to the power of let's say this n could be maximum of 9. So 10 to the power of 9. Yeah, it's a really big time complexity. But for the trimming, we can really make the testing cases really small. Yeah, but also we have this kind of condition. If it is equal to k, we can reduce. Yeah, basically I think it should be factorial of 10 maybe. I'm not sure. Maybe the time complexity maybe yeah, I'm not sure the time complexity. This is difficult to calculate. Yeah, we have the backtracking. We have the 10 different cases. For each of the number, we have 10 different cases. But for each case, for example, if it is the first number is 1, maybe the k is 1. So for the next number, it can only be 2. Yeah, it can only be 2. It is fixed. And then it can only be 0 or 2. I think it is 2 to the power of 10. That's gonna be the time complexity. Let's just check. Yeah, because for example, for the first number, if it is 1, the next number, if this k equal to fixed, if this k equal to 0 maybe, or maybe 1. So the next number may be 0 or maybe 2. So it's gonna have 2 different cases. So for the next number, yeah. So if the first number is fixed, if it is 1, we're gonna have a 0 or 2. And the next, for example, if it is 2, if this k is 1, it's gonna have 1 or 3. Yeah. But for the first one, we're gonna have 10 different cases. So it's gonna be 9 different cases. 9 times 2 to the power of 10. I think this is going to be the time complexity. So it is n times 2 to the power of n. So this is gonna be the time complexity. Yeah, because we can use examples. For example, for the first one, we can choose a 1. There are gonna be 9 different cases, and then if we choose a number 2, maybe k is 1, we have 1 or 3. It have 2 different cases, but how many of them? It is 2 to the power of n minus 1. Yeah, but basically we can use n times 2 to the power of n to calculate the time complexity. Thank you for watching. See you next time.